Okay, the last time that we met, we talked about some of the different IPv6 addresses that we will see. We talked about using a prefix. The /64 tells us where we draw our line for the network portion, and what left side is the network portion, right side is the interface ID. We talked about some of the different addresses that we will see out there. We talked about unicast. And with the unicast, we have global unicast, link local, or loopback, unspecified, unique local, and the embedded IPv4. Today we're going to talk specifically about the link local address. With the link local address, when you see FE80, any FE80 address is a link local address. Okay, so when you see that FE80, think to yourself, that is link local. And I can only use that to communicate within my local link or within my local network, my local subnet. A lot of times, the default gateway address for PCs, servers, and printers will be the link local address that is assigned to a router. Okay, the link local address that is assigned to a router. This link local address is going to show up automatically on any IPv6 interface or device that is turned on and configured. So our computers currently have a link local address. So if you go to your command prompt real quick and you do an ipconfig, we looked at this the other day, but we have a link local address for your wireless. So mine's FE80 $7C05:2868:608. If you guys tried to ping that address, it should be successful. I have my firewall off. But we're all on the local link, we're all on the same network. You would be able to ping that address. The actual range for a link local, as far as the first hectet is concerned, is between FE80 and FEBF. But we're almost always going to see that FE80. So again, FE80, link local, allows us to communicate on our local link. It's an address that shows up automatically on an IPv6 configured interface or device. The next type of IPv6 address that we're going to assign to our interfaces is known as an IPv6 global unicast address. Global unicast address. With the global unicast address, we're typically going to see this start out as 2001. In all the examples I just had you guys do with the compression, I started them off with 2001 because that's what we're going to see for a global unicast address. Global unicast addresses can be routed out on the internet. One thing you need to start thinking about with IPv6 is every address or every device is going to be assigned a global address. Every address that's assigned to a computer will be able to be routed out on the internet. With IP version 4, a lot of our addresses we assigned were NAT addresses, or those private addresses. And those private addresses could not be out on the internet unless we went through some type of network address translation. Network address translation is out. There is no network address translation with IPv6. You get a global unicast address, you can be routed out on the internet. We also have to stop thinking about wasting addresses with IPv6. With IPv version 4, we're all about saving and preserving addresses. IPv6, don't worry about wasting addresses because there are so many of them. So when we see that 2001, think to yourself, okay, this is a global unicast address. This is a unique address that's specific to this device, and it can be routed out on the internet. With a global unicast address, typically we will use a 314 type of rule. 314. The first 3 hectets are your global routing prefix. These are going to be assigned to you from either your internet service provider or whoever you're getting your addresses from. Those first 3 will be assigned to you. That's the 3 part of the 314 rule. The 1 is the subnet ID. You can freely subnet the global routing prefix that they give you with that subnet ID. And each subnet can have up to 65,000 hosts. So if you're a customer for Mid-Continent, and Mid-Continent's going to start giving you an IP version 6 address, you can freely subnet that and have 65,000 devices on your network. The last 4 hextets of the last 64 bits, so 3 hextets, 1 hextet, 4 hextets, represents the individual interface ID, or the individual computer. So that's the 314 rule with our global routing prefix. Okay, in packet trace, you can go ahead and get to the command line of your router. And the first question about continuous configuration dialog, we want to type in no. We do not want to get into setup mode. I'm going to get into privilege mode and then config T. And then I'm going to get into my fast Ethernet 00. So type in int fa0/0. The first thing I'm going to do is I'm going to enable IP version 6 on this interface. So I'm going to type in IPv6 enable and hit enter. Can anybody tell me what happens when I enter in that command? What address do you automatically get when you turn on IP version 6 on any device or interface? Your link local address. So when you configure IP version 6 on any interface, whether it's a router interface, you configure it on a Windows machine, you're going to get a link local address. So if I type in do show IPv6 int brief, I can see now that my fast Ethernet 00 has a link local address, FE80. When I see FE80, I know that that is a link local address. Okay? Notice my fast Ethernet 01 does not have an IP version 6 address because IP version 6 is not enabled on it yet. So our link locals are used to communicate within our local area network. That's typically going to be the default gateway address for a PC that's using this router as the default gateway. And then the global unicast address, which we'll set up here in a minute, is what's used globally out on the internet, used to be routed out on the internet. So inside of their interface, which we are, I want to type in IPv6 add for address. And just to show you the question mark key here again, if I hit the question mark key after IPv6 address, it either wants me to type in the word for a general prefix name, a link local address, or an IPv6 prefix, or to get it through auto configuration. We're going to manually set up an address like this here. So IPv6 address, we'll go 2001:CAFE:1. And then we need the slash, and the prefix length was going to be a 64. So having a prefix length of 64 is going to set the first 4 hextets as our global routing prefix, and the last 4 of just 1 here in this case as the interface ID. So now if I type in do show IPv6 int brief, I can see that I have my link local address and I also have my global unicast address. There's one more command that we need to do on a router to make it an IP version 6 router, and that's out of the interface. So I'm going to type in exit, and that's our IPv6 unicast routing. IPv6 unicast routing. That turns routing on for IP version 6, and it also is going to enable that Slack process for us. The last time we met, we talked about some different ways in which we can get IP addresses for IP version 6. We can go manually assign them like we just did here. We can get them through a process known as SLAC, or we can get them through a IP version 6 DHCP server. Well, when we do this here, this turns on the SLAC process. We're going to try to get that SLAC process to work now. I'm just going to minimize this. I'm going to drag up a PC. And if I'm going to connect the PC to the router directly, it's going to be a crossover cable. I'm going to go grab a crossover. And I'm going to go from the PC's fast Ethernet 0 to the router's fast Ethernet 0/0. We missed one step back on our interface up here, didn't we? What did we forget to do? No shut. Yep, forgot to turn it on. I need to do that. I need to go back into my interface FA 0/0 on the router and do a no shutdown. Turn it on. Okay, if you click on your PC and you go to the desktop tab and you go to the command prompt, if you type in right now, I think it's IPv6 config. Yeah, this is a proprietary packet tracer command. This isn't a command that you would use on a Windows machine. If I type in IPv6 config, I can see right now that all I have is that link local address. So I know it has a link local address because it's FE80. It also is labeled link local. It does not have a global unicast address at this point in time, but it would be able to communicate with that router. And let's just test that out. So if you go back to your router and you figure out what the IP version 6 link local address is, so I'm going to do a show IPv6 int brief. We should be able to ping that address from the PC. I'm going to do a ping. My address happens to be FE80 ::2E 2E0 :B0FF FEE7 :4101. And I'm getting a reply back. Okay, I want to get a global unicast address as well, so that this PC can be out on the internet. And again, the ways we can get it: manually assign one on the PC, we can get one through SLAC, or we can get one through DHCP. And I want to get one through SLAC here. So if I close the command prompt on the PC and go to my IP configuration tab, under the IP version 6, we can see either DHCP, autoconfig, or static. And we're going to do it through autoconfig. And when you type autoconfig, you're going to see an address start to show up there, kind of in gray. Once I select autoconfig, I'm going to close the X, go back to my command prompt, and issue that IPv6 config command. And what I see here is that it automatically got an IP version 6 unicast address for me right through the SLAC process. I didn't have to go in there and manually assign it. What it did is it took that global routing prefix that I had set on the router. If I look at my router, that's the same prefix because I use the /64, 2001 CAFE AAA1. This starts with the same thing, 2001 CAFE AAA1. And then what it uses is it uses the EUI64 process. If you remember, for the interface ID, what it does is it takes the MAC address, it flips that 7th bit, so it was a 0, it became a 2, it inserts FFFE right into the middle, and then uses the other part of the MAC address. So if not sure if this works in packet tracer, but I'm going to try to find my MAC address. ipconfig/all. There it is. My ipconfig/all. Here's my MAC address. 00E08F043380. So if I split that right in half, which would be right here, it's going to insert FFFE into it. Here's the FFFE, inserts that right into the middle of the MAC address. And then it takes the 7th bit here, which happens to be 0, and it flips it to a 2. So that's how the SLAC process works. It's through SLAC, your computer contacts the router, asks the router for an IP address, the router gives it the prefix, and then the interface ID is made up through that EUI64 process. Again, if I did not want that to happen, I can either statically assign one, so I'm going to manually put one in here and type it all in, or I can get one through a DHCP server. Another process is to use a combination of both, where you get maybe your prefix and your default gateway through SLAC, and then you get your DNS information through DHCP, because SLAC cannot offer you the DNS information. Okay, our link local addresses on our Cisco routers are automatically generated for us. As soon as I enabled IPv6 on my fast Ethernet 00, this link local got automatically generated for me. But I can also manually assign that one as well. So if I go into my config T mode, go back into my interface fast Ethernet 0/0, I can type IP address FE80::1, and then I use the keyword at the end, link, IPv6 address, my fault. IPv6 address FE80::1 link local. So now if I do a show IP int brief IPv6 int brief, I can see that the link local is FE80::1. And you may just want to do that, manually set your link locals, because that link local becomes the default gateway for all PCs in your network. And it may be easier for you just to type in the default gateway of FE80::1 than having to type in what it was set to before, which was FE80::2E0:B0FF::FEE7:4101. So a lot larger there. Okay, we're going to talk a little bit about multicast. We said with IPv6 there are no broadcast addresses. Instead, we have some multicast addresses that we need to be aware of. And there are two types that you need to be aware of. There's the assigned multicast, and then there's the solicited node multicast. The assigned multicast address is going to be assigned to a device or a computer based upon certain criteria. For example, there is the all nodes multicast address, FF02::1. When we start to see FF02, that should trigger to you, that's multicast. FF02 is multicast. FFE80, that's our link locals, and 2001, that's our global unicast. So we're going to start to see kind of these same numbers over and over again. 2001, that starts with 2001, that's a global. FE80 is our link local, and the FF02 is our multicast address. So every single device that has IPv6 enabled is going to be part of this FF02::1 multicast address. So when I want to send a message to every device running IPv6, instead of sending to a broadcast like I did with IPv4, I send to that FF02::1. The other one that we need to be aware of is FF02::2. We have : 1, which is everybody, and : 2, which is the all routers multicast group. And how do you become a part of that multicast group? Well, you enable that IP version 6 unicast routing command on the device, and now it's considered a router, and now it becomes part of that all routers multicast group. So if I go back to my router inside of Packet Tracer, and I get into privilege mode, if I type in show IPv6 int, this is going to show my interfaces that are running IP version 6. And I have one here, it's fast Ethernet 00, that's the one I enabled it. I can see my global unicast address. And I can see these multicast groups that I joined. FF02 : 1. FF02 : 2. So it's part of the all multicast group and part of the IP version 6 multicast group. And these addresses are going to become important to us. And we'll talk about some of these addresses as far as what they're used for coming up here. We see one more here, the FF02 : 1 : FF00 : 1. That one is known as the solicited node multicast address. Essentially, every single interface that gets configured with IP version 6 also gets this solicited node multicast address, and it relates directly to that interface. We talked about the ARP process with IP version 4. With ARP, we knew an IP address, but we needed the MAC address. And the ARP process was a broadcast. We shouted out on the network. So we knew the IP, we needed the MAC in order to communicate. But we don't have ARP. We don't have broadcast in IP version 6. So we don't have ARP with IP version 6. So instead, what we use is we use neighbor solicitations in order to find the MAC address of a computer. So if I want to communicate with another device through a MAC address, what I'm going to do is I'm going to send a neighbor solicitation message to the solicited node multicast address. Basically, you're going to send a message to that device saying, I need your MAC address, and you're going to reply back. That's more efficient than doing a broadcast on the network, because we're sending it directly to the device that we're looking for the MAC address of. Sending it directly to that device. So what we do for the solicited node multicast address is we use this FF02 : FF, and then we take the last 24 bits of our global routing address, and we insert that at the end. So this particular device, the global routing unicast address is this, 2001 0DV8, all the way to the last 24 here, which is 000010. So for the IPv6 solicited node multicast address, FF02 : 0 FF, take those last 6, insert them there. So if I look at my router on Packet Tracer, here is my global unicast address. The last 6 of these would be all zeros, and then 1. So I'd have 5 zeros and then a 1. So that solicited node multicast address turns into FF02 : 1 FF, which is always going to start with. And then we take the last 6, which were 5 zeros, and then the 1, and we insert that at the end. And that's used for our solicitation messages. So we have all these different addresses that we're going to see with an IP version 6 enabled interface. We're going to see that link local with the FE80. We're going to see that global unicast with the 2001. And then we're going to see all of these different multicast addresses that we join, or these groups that we join. FF02 : 1, that's everybody that's running IP version 6. This is a router, so it joins the FF02::2, and it also joins the solicited node, FF02::1:FF00:1. So at the very minimum, you're going to have at least a link local and your all nodes multicast. On a router, you're going to have at least the link local, the all nodes, and the all routers. When you configure that global unicast, you add that one, and you add your solicited node as well. So we have a lot of different addresses that we're all listening for in IP version 6. So let's talk a little bit about how those multicast addresses are used. Through IP version 6, we use ICMP. In ICMP, typically we think about pinging. Ping traffic is ICMP traffic. But with IP version 6, we have a few other messages that go along with ICMP. The first are our router solicitations and our router advertisements. Through router solicitation, that's our Slack process. We're asking for a router to give us IP address information. So when we want to solicit a router, we're going to use that FF02::2 address. We're looking for a router, so we send it to the multicast address of all routers. So that's where that address comes into play. Then, when that router responds back to us to that router advertisement message, he's going to respond back to the FF02::1, the device, or the all devices. So we have those multicast addresses working for us here with our router solicitations and our router advertisements. The next we have our neighbor discovery through neighbor solicitations in ICMP version 6. Through neighbor solicitation or neighbor advertisements, we use it for address resolution to get a MAC address, because there is no ARP, or through what's known as DAD, or duplicate address detection. First, through address resolution. Essentially how this works is like the ARP process. We send out a solicited node multicast address to the device that we are looking for their MAC address. So in this example, it says, I need the Ethernet MAC address of the device that has this unicast address. And the unicast address is 2001 DB8 ACAD:1:20. So we're sending a message directly to the PC saying, I'm asking for your MAC address so I can communicate with you. Can you send that back to me? And he would send it back to him through the address resolution process. The second there is the DAD process, the duplicate address detection. So before I use this address, is anyone else on the link using this global cast address? So before I assign myself an address through Slack, it goes through the DAD process and asks everybody else on the network, are you using this address? Is this address available for me to use? Not going to hear anything back, so he knows that that address is free and he can use it. So our multicast addresses are going to be used for specific functions, typically through ICMP version 6. And it's either going to be for our neighbor discovery protocol to get MAC addresses, or for our router solicitation so we can get IP address information. Those are our main uses for our multicast addresses. Other uses are also for the data, that duplicate address detection.